Hey, welcome back. Let's take a look at metallic bonds. Metallic bonds involve elements that are found in the D block. These are also called transition metals due to the fact they can have different states. And this is because of something unique with their electrons. So let's take a look. If you remember before, we had the 4s orbital we would fill, and then we would fill a 3d orbital, and then we would go to the 4p. And we filled the 3d out of order because it was slightly more energetic, even though it was on the third energy level. So because of this, everything in the d orbital, or the d block, will have one electron, between 1 and 10, most of them less than 10, and 0 p orbitals. Now, the orbitals in the d and the p can all overlap, meaning the electrons will move around. This is called delocalization. So if I have some nuclei of some metals here, my electrons will not be fixed, but will be shared throughout all the bonds. And you can see it's almost like a C here. It's almost like the positives are floating around, and that is called a sea of electrons. So the delocalization of the electrons is known as the sea of electrons concept. And this gives metals all their properties. First of all, metals can be ductile, which means you can pull them into wire. They can be malleable, meaning you can hammer them into sheets, okay, because these positives are going to move around. They're not fixed. They're going to slide and move around over each other. So that makes them ductile and malleable. Also, they are good conductors of both heat and electricity. This is also due to the sea of electrons concept, which makes metals ductile, malleable, and great conductors. That's all for metal bonds. I'll see you next time. Bye-bye.